Alright, this is a glossary of terms related to the nuclear power article. Glossary of nuclear terminology. 1. Nuclear fuel. Material used in a nuclear reactor to produce energy through nuclear fission. Common types include uranium and plutonium. 2. Fuel fabrication. The process of transforming uranium into nuclear fuel rods, involving several stages to produce fuel assemblies. 3. Fuel assembly. A structure that contains multiple fuel rods, forming a major component of a reactor core. It is designed to specific reactor types. 4. Fissile material. Material capable of sustaining a nuclear fission reaction, such as uranium-235, U-235, and plutonium-239, Pu-239. 5. Fission. The splitting of an atomic nucleus, resulting in the release of energy and neutrons, which can initiate further fission events. 6. Uranium enrichment. The process of increasing the percentage of U-235 in uranium to make it more suitable for use in reactors. Enrichment levels for light water reactors can reach up to 4.8% U-235. 7. Natural uranium. Uranium that has not been enriched and contains approximately 0.7% U-235, used in some heavy water reactors. 8. Burn-up. A measure of how much energy is extracted from nuclear fuel, expressed in gigawatt-days per ton of uranium, GWD/2. 9. Advanced burnable absorber. Materials added to fuel to help manage reactivity during the fuel cycle, such as gadolinium used in pressurized water reactors, PWR. 10. Zirconium alloy. A metal used to clad and seal fuel rods, chosen for its ability to withstand high temperatures and corrosion in a reactor environment. 11. Ceramic pellets. The standard form of nuclear fuel, usually made of uranium dioxide, UO2, which are stacked in fuel rods. 12. Mixed oxide, MOX, fuel. Fuel that contains both uranium and plutonium oxides, used in some reactors as an alternative to conventional uranium fuel. 13. Light water reactor, LWR. A type of nuclear reactor that uses ordinary water as both coolant and neutron moderator. Common forms include pressurized water reactors, PWR, and boiling water reactors, BWR. 14. Pressurized heavy water reactor, PHWR. A type of nuclear reactor that uses heavy water, deuterium oxide, D2O, as a coolant and moderator, often using natural uranium as fuel. 15. UF6, uranium hexafluoride. A compound used in the uranium enrichment process, where uranium is converted to this gaseous form. 16. UO3, uranium trioxide. A compound from which pure uranium dioxide, UO2, is produced for fuel fabrication. 17. Core monitoring. Technologies used to provide real-time information on the condition and performance of fuel within a reactor core, enhancing operational efficiency. 18. International Accident Tolerant Fuel Program. An initiative focused on developing new types of fuel that can better withstand potential accidents in nuclear reactors. 19. Utilities. Companies that operate nuclear power plants and provide electricity to consumers. 20. R&D, research and development. Activities focused on developing new technologies and methods for improving nuclear fuel performance and safety. This glossary provides a foundational understanding of the terminology associated with nuclear fuel and its fabrication. Glossary of nuclear terminology. 1. Uranium dioxide, UO2. A compound of uranium that is the primary fuel form used in nuclear reactors. It is produced from uranium hexafluoride, UF6, or uranium trioxide, UO3. 2. Uranium hexafluoride, UF6. A gaseous compound of uranium used in the uranium enrichment process. It is the starting material for converting to UO2. 3. Uranium trioxide, UO3. A solid compound of uranium that can be converted into UO2. It is used as an intermediate in the fuel fabrication process. 4. Chemical conversion. The process of transforming uranium compounds into UO2, typically from UF6 or UO3, involving various chemical reactions. 5. Dry process. A method for converting UF6 to UO2, where UF6 is heated and reacted with steam to produce solid uranyl fluoride, UO2F2, which is then reduced to UO2. 6. Wet process. A method for converting UF6 to UO2 that involves creating a slurry with water and UO2F2, followed by reactions with ammonia or ammonium carbonate to produce ammonium diuranate, A2, or ammonium uranyl carbonate, AUC. 7. Ammonium diuranate, A2. A compound produced in the wet conversion process, which is eventually converted into UO2. 8. Ammonium uranyl carbonate, AUC. Another compound produced in the wet conversion process, also ultimately converted into UO2. 9. Homogenization. The process of blending UO2 powders to achieve uniformity in particle size distribution and specific surface area before pellet fabrication. 10. Additives. Substances added to UO2 powder to enhance pellet microstructure and density, such as U3O8, lubricants, and burnable absorbers. 11. Green pellets. The unsintered, pressed pellets formed from conditioned UO2 powder before they are heated in a furnace. 12. Sintering. A process where green pellets are heated to a high temperature, about 1750 degrees Celsius, in a reducing atmosphere to consolidate and strengthen them. 13. Pellet microstructure. The arrangement and distribution of particles within a UO2 pellet, which affects its performance in a reactor. 14. Burnable absorber. Materials added to fuel pellets to absorb neutrons early in the fuel cycle, such as gadolinium, to manage reactivity. 15. Gadolinium. A chemical element used as a burnable absorber in fuel pellets, allowing higher initial fuel enrichment without excessive reactivity. 16. Plenum space. The free space left at the top of the pellet stack within a fuel rod, allowing for thermal expansion and gas accumulation. 17. Zirconium alloy, zircalloy. An alloy used for cladding fuel rods, chosen for its low neutron absorption and corrosion resistance. It typically includes tin, niobium, iron, chromium, and nickel. 18. Fuel assembly framework. The structural components that hold the fuel rods in place within a reactor, designed to precise specifications to ensure stability and safety. 19. Pressurized water reactor, PWR. A common type of nuclear reactor that uses water as both coolant and neutron moderator, operating under high pressure to prevent boiling. 20. Control rod. A component of a nuclear reactor used to control the fission process by absorbing neutrons. 21. Guide thimble. An empty space in a fuel assembly that can accommodate control rods or instrumentation. 22. Quality assurance, QA. A systematic process to ensure that all components and processes meet specified standards and regulations, critical in nuclear fuel fabrication. 23. Criticality safety. Measures taken to prevent uncontrolled nuclear fission in facilities handling fissile materials, ensuring uranium enrichment levels remain below critical thresholds. 24. Neutron absorption cross-section. A measure of the probability of a neutron being absorbed by a nucleus, which is critical in evaluating materials used in nuclear reactions. 25. Fluoride handling. The management of hazardous fluoride compounds during the conversion processes, which requires strict safety protocols. Glossary of nuclear terminology. BWR, boiling water reactor, a type of nuclear reactor where water is boiled directly in the reactor core to produce steam for driving turbines. Fuel rod, a cylindrical component containing nuclear fuel pellets, usually clad in a material like zirconium. Fuel assembly, a structured group of fuel rods arranged in a specific configuration to optimize the nuclear reaction and coolant flow. Zircalloy, a zirconium alloy commonly used as cladding for nuclear fuel rods due to its low neutron absorption and corrosion resistance. Zirconium clad, the practice of enclosing uranium oxide pellets in a zirconium alloy tube to contain radioactive materials and facilitate heat transfer. Cruciform control blade, a control rod shaped like a cross that regulates the nuclear reaction by absorbing neutrons. Pin geometry, the arrangement and shape of fuel rods within a fuel assembly, often specified as square lattices, example 6x6, 10x10. Neutron moderation, the process of slowing down neutrons to increase the likelihood of fission in nuclear reactions. Control rods, rods made of materials that absorb neutrons, used to control the rate of the nuclear reaction. Load following, the ability of a nuclear reactor to adjust its power output in response to varying electricity demand. PHWR, pressurized heavy water reactor, a type of reactor that uses heavy water, D2O, as both a coolant and moderator, allowing it to use natural uranium fuel. CANDU, Canadian deuterium uranium, a specific type of PHWR designed in Canada that can utilize natural uranium as fuel. AGR, Advanced Gas-Cooled Reactor, a British-designed reactor that uses carbon dioxide as a coolant and graphite as a moderator. RBMK, Reactor Bolshoi Moshchnosti Konolnya, Soviet-era reactor design that uses light water for cooling and graphite for moderation. Fast Neutron Reactor, FNR, a type of reactor that uses fast neutrons to sustain the fission reaction, often utilizing plutonium or uranium-235. Fast Breeder Reactor, FBRA-FNR, designed to produce more fissile material than it consumes, breeding plutonium from uranium-238. Oxide ceramic fuel, a form of nuclear fuel made from uranium dioxide, UO2, in a ceramic form, commonly used in many reactor designs. Mixed oxide fuel, MOX fuel that contains a mixture of plutonium oxide and uranium oxide, used in certain types of reactors to recycle plutonium. Thermal neutron spectrum, the range of neutron energies in which thermal neutrons, slow neutrons, interact effectively with fissile material. Pellet cladding gap, the space between the fuel pellet and the cladding tube, which is maintained to accommodate thermal expansion. Burn-up, a measure of how much energy is produced from a given amount of nuclear fuel, usually expressed in gigawatt-days per metric ton, GWD/T. Fission product gases, gases that result from the fission process, such as xenon and krypton, which can leak through damaged fuel rods. Cladding breach, a failure in the fuel rod cladding that allows radioactive material to escape into the coolant. Fuel fabrication, the process of converting uranium and other fissile materials into usable nuclear fuel assemblies. Uranium enrichment, the process of increasing the proportion of uranium-235 in uranium, often necessary for fuel used in reactors. Fuel cycle, the series of processes involving the production, use, and disposal of nuclear fuel. Lead test assemblies, experimental fuel assemblies used to test new designs or materials before full-scale deployment. Accident-tolerant fuel, new fuel technologies designed to improve safety and performance under accident conditions. Glossary of nuclear terminology. LWR, light water reactor, a type of nuclear reactor that uses ordinary water, light water, as both coolant and neutron moderator. Fuel fabrication, the process of manufacturing nuclear fuel assemblies from uranium and other fissile materials. Joint venture, a business arrangement where two or more parties agree to pool their resources for a specific goal, often creating a new entity. Global Nuclear Fuels, GNF, a joint venture formed by General Electric, Toshiba, and Hitachi, known for producing BWR fuel. It has two branches, GNFA, Americas, and GNFJ, Japan. BWR fuel, nuclear fuel specifically designed for use in boiling water reactors, typically comprising zirconium-clad uranium oxide pellets. Nuclear Fuel Industries, NFI, a Japanese company involved in the fabrication of nuclear fuel, which became wholly owned by Toshiba after acquiring the remaining shares. REPU, reprocessed uranium that has been recovered from spent nuclear fuel through reprocessing, allowing it to be reused as nuclear fuel. ERU, enriched reprocessed uranium that has undergone enrichment to increase the concentration of fissile isotopes. MOX, mixed oxide fuel, a type of nuclear fuel made from a mixture of plutonium and uranium oxides, used primarily in certain types of reactors to recycle plutonium. Melox plant, Arava's facility in Marcoule, France, dedicated to the fabrication of MOX fuel with a capacity of 195 tons per year. Sellafield MOX plant, a UK facility that was designed to produce MOX fuel but was never able to reach its intended capacity before closing in 2011. Zheleznogorsk MOX plant, a Russian facility that began operation in 2015 for the production of MOX fuel, primarily for fast reactors. Rakashomura MOX plant, a planned facility in Japan expected to be operational by 2022 for the fabrication of MOX fuel. Savannah River MOX plant, a U.S. facility intended to convert weapons-grade plutonium into MOX fuel, which has since been terminated. Fukushima accident, a nuclear disaster in Japan that affected public and regulatory attitudes towards nuclear fuel use, particularly MOX fuel. Secondary supply, the process of obtaining nuclear fuel from recycled materials rather than newly mined and enriched uranium. Fabrication capacity, the maximum amount of nuclear fuel that a fabrication facility can produce in a given time frame, often expressed in tons per year. Market demand, the need for nuclear fuel fabrication services, influenced by reactor operating strategies, new reactor builds, and recycling practices. Kazatomprom, a Kazakh state-owned company involved in uranium production and nuclear fuel fabrication, aiming to become a significant supplier in the global market. Enrichment demand, the requirement for enriched uranium, which is necessary for certain types of reactors to sustain fission reactions. Glossary of nuclear terminology. Accident-tolerant fuel, ATF, new technologies designed to enhance the safety and performance of nuclear fuel during incidents by using advanced materials and designs for cladding and fuel pellets. Arava, a multinational group specializing in nuclear power and renewable energy, involved in various nuclear fuel activities. BWR, boiling water reactor, a type of light water reactor that uses boiling water to generate steam for electricity production. Ceramic fuel, nuclear fuel typically made from uranium dioxide, UO2, or other compounds, characterized by high melting points and thermal stability. Encore ATF, a specific accident-tolerant fuel developed by Westinghouse featuring high-density uranium silicide fuel pellets. Ferritic/martensitic steel alloy, a type of steel used for cladding in some advanced fuel concepts, known for high mechanical strength and oxidation resistance. GNF, Global Nuclear Fuels, a joint venture that produces fuel for nuclear reactors, known for BWR fuel. HALEU, High-assay low-enriched uranium. Uranium with enrichment levels between 5% and 20% U-235, used in advanced reactors. Light bridge metal fuel, an advanced metal fuel concept with potentially accident-tolerant characteristics, utilizing a unique geometric design for heat transfer. MOX fuel, mixed oxide fuel made from a blend of plutonium oxide and uranium oxide, used in some light water reactors. Remix fuel, regenerated mixture of fuel made from a non-separated mix of recycled uranium and plutonium, designed for use in VVER reactors. TRISO fuel, tristructural isotropic fuel particles used in high-temperature reactors, characterized by a protective coating that contains fission products at high temperatures. Uranium oxide, UO2, the most common nuclear fuel, primarily used in light water reactors, known for its high melting point. Uranium zirconium alloy, a type of metallic fuel alloy that combines uranium with zirconium to enhance performance characteristics. VVER, water energetic reactor, a type of pressurized water reactor developed in Russia. Vibropacked MOX, VMOX, a Russian method for producing MOX fuel where blended powders are packed directly into cladding tubes for sintering. Zirconium alloy, commonly used cladding material for nuclear fuel rods, known for its low neutron absorption properties. Key terms related to fuel fabrication. Sintering, the process of compacting and forming a solid mass of material by heat without melting it to the point of liquefaction. Cladding, the outer layer of a fuel rod, typically made from materials like zirconium, which protects the fuel and contains fission products. Pressing, a method used to form fuel pellets from powdered fuel material before sintering. Fissile material, material capable of sustaining a nuclear fission chain reaction. Enrichment, the process of increasing the proportion of fissile isotopes in uranium, such as U-235. Reprocessing, the chemical separation of fissile material from spent nuclear fuel for reuse.